All right, if you're looking for number 14, just skip ahead, but we're going to do these in order. So we know that these are two chords. We know that cutie, oh, how cute, is 4, and Petey, cutie Petey, is 10, and RT is 8, and we're asking for the length of ST. So the rule is 4 times 10 is equal to 8 times X, what we are looking for. So 40 divided by 8 is 5. Number 10, 86, 144, we're finding DF. It's really just minus 360, so 360 minus 86 minus 144 is 130 as our final answer. Now let's see, LQ is 6, QM is 4, NQ is 7, and we're looking for this length here. So again, hopefully you remember of 9. What are you going to multiply? Those guys there is equal to these guys here multiplied. 7 times X. Now remember, it works because, what this is, 24 over 7. It works because of similar triangles, and you set up ratios. But ratios are difficult because you have to remember which goes on top and bottom, and it's just crazy. Much easier to cross multiply and use this idea of this times this is equal to this times this. Harder to remember why it works, but it works out real well. So we get A as our answer. For number 12, it's tangent to the circle, which means that this is 90 degrees because this is the radius. What else do we have? We have xy, this whole thing here is 5, and xz, this whole thing here is 4. So this is 3. What are we looking for? Circumference. 2 pi r, people. So 6 pi is our answer. Area of regular hexagon, you've got that the apothem is 8 root 3, which for the hexagon, if you remember, this is 8. And then this here is our 16. So what are we looking for? The area of the whole thing. So we're looking for 1/2 of the base times the height for the area of the triangle. So we have, this is the area of one triangle. And then, whoa, how did that become a 5? Nobody knows. Now it's a 3. Yay. And then I multiply that by, of course, 6 because it is a hexagon. And 6 times 64 is 384 for our answer. All right, so we're looking at this and trying to describe what it is that is happening here. So you see this little dot here, that was probably given. You see this little line here, that was probably given. But then what happened is we drew this little line here, which created this part of the rhombus here. And then if you can tell, this arc is really coming from here, so that means we probably created a rhombus here and a rhombus here. So what is it that we are doing? We're creating a perpendicular, not an equilateral triangle. We did not bisect a line segment because if you recall, it was a line, so that's key. And it wasn't bisecting of a given angle because we didn't have that. But what we did find is perpendicular to a line through a point off of the line. So this is the point off of the line, and then we're drawing a perpendicular to that line. So that would be it.